Hello viewers, in today's class we are going to take an important topic in integration, and the topic is integration by parts, right? So here we'll discuss how to use the method of parts to integrate the product of two functions, right? So let us start. Suppose we have the product of two functions, say u and v, right? And u and v are the functions of x, that is u is the function of x and v is also a function of x, and we have to integrate the product of these two functions with respect to x. So the integration by parts method says that if we have the product of two functions and we have to integrate the product, then the formula goes like this. We have the first function, this is first function, and this is the second function, right? So we have first function, then integral of second function, minus we have integral of the derivative of first function, that is u, then we have the integral of second function v, and then we have to integrate this entire function with respect to x. So this is the formula for the integration by parts, right? So let us do some problems. Now let us integrate the product of x and log x, right? And let us call this integral as I. Now here we have the product of two functions. X is the algebraic function and log x is the logarithmic function, right? Okay, so now we have to integrate the product of these two functions. Now here one question arises, that is, which function is to be treated as the first function and which is to be treated as second function. So here we'll make use of one trick or a method to find out or to decide which function is to be treated as first function and which is to be treated as second function. So the rule goes like this, and the rule is I late, right? I late. So here the letters, this I is it stands for inverse trigonometric function, right? Inverse trigonometric function. And L stands for logarithmic function, A stands for algebraic function, and T stands for trigonometric function, and E stands for the exponential function, right? So we'll take the order of these letters, and here x is the algebraic function and log x is the logarithmic function, right? And we see that L comes before A, and so log x will be treated as first function, right? Because L comes before A, so this function is treated as first function, or this is treated as u, right? And x is the algebraic function, so this function will be treated as the second function. And let us apply this rule to integrate this function. So let us substitute the value of u and v in this formula. So we have I is equal to, here we have u, and u is log x, and then we have integral of v, and v is x, right? So we have x dx minus integral of the derivative of u, and u is log of x, and then we have the integral of v, right? And v is your x, right? So we have dx and here we have dx. Now the integral of x is x square over 2, and we have the integral sign here, so derivative of log x is 1 over x, and the integral of x is x square over 2, right? And here we have dx. So now simplifying it, we have x square over 2. Here we have the constant of integration as c, so we have x square over 2 log x minus, and here we have 1 over 2 integral, and here 1x get cancelled, so we have x dx plus c, right? So now this can be written as x square over 2 log x minus half, and integral of x is x square over 2 plus c, right? So now this can be written as x square over 2 log x minus x square over 4 plus c. So this is the required integral of the product of these two functions. Now let us take this problem. Here we have to integrate x multiplied by tan inverse x dx, right? So now here we see that this is the algebraic function, and this is the inverse trigonometric function, right? And here we see that I stands for inverse trigonometric function, and I comes before a, that is algebraic expression function. So I is to be taken as the first function, right? First function. It means we have to take u as tan inverse x, right? And this is to be treated as the second function, right? So v is our x, right? So now let us substitute these values in this formula, right? So I becomes u integral of v, so u is tan inverse x, then integral of x dx minus integral of the derivative of tan inverse x, because u is tan inverse x, and then we have integral of x dx, and here we have dx, right? So the first step is to decide which function is to be taken as first function and which is to be taken as second function, and once we decide this order of the function, then we'll apply this rule. Now here we have tan inverse x, then integral of x is x square over 2 minus integral of the derivative of tan inverse x is 1 over 1 plus x square, and this is the integral of x is x square over 2, right? Okay, now we can simplify it. So writing it like this, x square over 2 tan inverse x minus will take half outside the integral sign, so we have x square over 1 plus x square dx, right? Okay, so now our aim is to integrate this integral, this one. So what we will do, let us integrate it separately. So let us call it I1. So we have I1 equal to integral of x square over 1 plus x square dx, right? Okay, so now the numerator is x square and the denominator is 1 plus x square, so we can write x square as 1 plus x square minus 1 over 1 plus x square dx. So this expression can be written like this, right? So from here we'll break this function. So this function becomes integral of 1 plus x square over 1 plus x square minus 1 over 1 plus x square, right? Okay, now this can be further written as 1 plus x square and 1 plus x square get cancelled, so we have 1 minus 1 over 1 plus x square, right? So now the integral of 1 is x, and the integral of 1 over 1 plus x square can be written as tan inverse x, right? Now we'll substitute the value of I1 in this expression. So we'll have I is equal to x square over 2 tan inverse x minus half of x minus tan inverse x plus c, where c is the constant of integration, right? Now this expression can also be written as I is equal to x square over 2 tan inverse x minus half x plus half of tan inverse x plus c, right? Okay, so we can also write it like this, taking tan inverse x and tan inverse x common. So we can take half tan inverse of x as common, and we can write here x square plus 1 minus half x plus c. So this is the required integral of this function, right? X multiplied tan inverse x.